Okay, so today, I don't know what's going on here. Today we are working with the law of cosines. Okay? So the law of sines is a nice proportion, easy to solve. However, we have that ambiguous case that can make our problems a little tricky, right? Law of cosines, the formula isn't quite as nice to solve. However, if we use the law of cosines, we do not have to worry about having no solution or two solutions. It's always just one straight shot answer. Okay? So here is the law of cosines. Okay? You don't have to write all three of them down because they're just different versions of each other. But if you'd like to write them all down, you can. Okay? After you write at least one of them down, I'll show you the pattern. Just remind you of the pattern. Okay, so what I want you to notice is that any version of this formula uses all three sides. Okay? Little a, little b, little c are using all of those. But only one angle is used. Okay? The angle that is here matches the side right here. And then the other two sides are sprinkled in between. Okay? So if you know one, you know all three, but that's the pattern, okay? This loner side over here matches the loner angle in the formula, okay? Does anybody remember when we use the law of cosines? Side angle side would be one of them. What? One more case. That's the ambiguous case. Yes, say somebody whispered it over here. Side, side, side. These are the two times we get to use the law of cosines. Okay. So here we go. Here is our first example. So 55 degrees, B is 3, C is 10. Okay, what set of given information do we have? We have side angle side, which means we need to use the law of cosines. Okay, now the law of cosines formula involves all three sides and one angle. That being the case, what do we have to solve for in this problem first?
Side A.
Side A. Okay. So let's apply our formula. We know that A squared should equal B squared plus C squared minus 2BC times the cosine of 55 degrees. So side squared plus side squared minus 2 times side times the cosine of the opposite angle. No, that's not what I wanted to do. Okay, so with your calculators, on the right side of your equation, put that in all at once. There is no point to doing things individually, okay? We have nice calculators where you can see everything displayed. So we are going to take 3 squared plus 10 squared minus 2 times 3 times 10 times the cosine of 55 degrees. Then what do we have to do with that? What? Take the square root. Leave this in your calculator. Okay, we can do a lot of our work on the calculator. We've set up the problem. That's all I need to see. Everything else can be done on the calculator. So now we're going to take the square root of that number. And so side A is 8.64. Okay. You can use that rounded answer. I'm going to go ahead and store this in alpha A for side A because I know I may have to use it again later. Okay, you can use a rounded answer if you'd like, or you can use the store feature if you'd like. Okay. Okay. Now this is what we have. Okay. We need to find angle B and angle C. Does it matter which one we find first? Probably not. Does anybody have any ideas of how we want to find it?
Can we rewrite the equation for cosine to make it equal with the cosine of the
Okay, we can use the law of cosines and we'd have to solve for the cosine of an angle.
Use law of sines.
It is possible for us to switch to the law of sines. Okay? Now, here is my warning. Is the law of sines easier to use? Yes, it is. However, we have the ambiguous case. If you take a look at this, we now have side angle if you exclude that 3 right there. Okay? Or side angle if you exclude that. Okay? And when we have side angle, what do we have to be careful of? Okay, we have to be careful of the ambiguous case. I will tell you right now, with the law of cosines, it is not possible to get a second triangle. It is not possible, okay? So if you use the law of sines, if you switch to the law of sines on a side angle side or a side problem, that is fine, but be careful. Because you know that the law of sines, okay, that first angle that you find with it, it could be an acute angle, it could be an obtuse angle, okay? So if you switch to the law of sines and your triangle does not make sense, then you need to go back to that angle you found with the law of sines and you need to choose its supplement instead. Okay? So if you're worried about having to think about that, sticking with the law of cosines would be a very safe bet. Yes.
So, like, how come cosine can't form, like, 2 triangles?
Because with, like, it's only the case where we have those, like, you know that picture I showed you yesterday with, like that side too short? That's not going to happen here. There's always going to be a way to make a triangle if it's side angle side. Or, obviously, side, we can never have a second triangle with. It's just the right combination of 2 sides at an excluded angle that we have that possibility of 2 triangles.
Okay.
Does that make sense?
Yeah.
Okay. So, if you're going to switch to the law of sines, you are more than welcome to. Just make sure your triangle makes sense. If it doesn't make sense, you have to go back to that angle you found with the law of sines and choose its supplement. What do I mean by your triangle not making sense? that would be a problem. Okay, so two problems. Your angles aren't adding up to the right number. Your angles and sides don't make sense. Okay, so if you have a really small angle across from a big side, that's probably not okay compared to the rest of your triangle. So you got to look at your triangle and make sure it makes sense. Okay. So I'm going to go ahead and I'm going to stick with the law of cosines just so we can practice the law of cosines formula. Because when we solve for angles, the law of cosines, we have to be careful with our algebra. Okay. But once we find that second angle, the third angle, we can use the 180 rule, okay? So which angle would you like to find first? Angle B, sure. So that means that we would have to choose B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. Okay. Let's talk about how we solve this problem. What do we need to do first? Okay, we're going to have to square all those things. What can we move over to the left side with subtraction? What? Okay, so we can take 3 squared and we can subtract over the A squared and we can subtract over the 10 squared. Okay, so we have this negative 165.585 equals negative 2 times 0.864 times 10 times the cosine of B. Right? Do I add that over? No. How do we have to move that over? Division. So I'm going to keep this in my calculator. We're going to divide. Since we're dividing by more than one thing, I'm going to put parentheses. Negative 2 times side A times 10. We get that. What does that equal? That equals the cosine of B, which means in our calculator we need to do what?
Inverse.
Okay, we need to do the inverse cosine of that answer. Leave it, all those decimal places in there. Okay, so angle B is 16.53 degrees. Then what you can do, okay, we don't have to worry about the law of cosines anymore. We now just have our third angle to find, okay? So we can take 180 minus angle C minus 55, or angle B, excuse me. And so angle C is 108.47 degrees. Okay. So let me tell you what would have happened. If we would have used the law of sines, we would have not gotten the 108.47. We would have gotten the 81 point whatever. Okay? And we would have had to use the ambiguous case to get that right. So if you have the side angle side case and you're going to switch to the law of sines, it's going to be best to try to get the smaller angle first with the law of sines and then use the 180 rule for the bigger angle. Okay? But you still have to make sure that your triangle makes sense. Okay? Because really, law of cosines is kind of a lot more work, isn't it? Okay? But if you want to know 100%, I know this is going to work, the law of cosines will do that for you. All right, let's look at a side, side, side case. Okay. Here, without even drawing a triangle, we have three sides. So side A is 34, side B is 20, side C is 18. We need to find an angle, and it doesn't matter which one we choose first. However, if you could potentially switch to the law of sines, it's going to be better to use the law of cosines for your biggest angle. The law of sines, the only way to get the obtuse angle is the ambiguous case, okay? Because our inverse sine doesn't give us an obtuse angle. It only gives us a measure between 0 and 90 degrees, okay? Or really negative 90 to 90 degrees, okay? So the law of cosines is best for an obtuse angle, okay? Does every triangle have an obtuse angle? No, but we don't know if it does or not. So if you had side, 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 I would choose the biggest angle to find first, and then switching to the law of sines would be fine. All right, so which one would be the biggest angle? A. So we need to have A squared equals B squared plus C squared minus 2 times A times 2 times B times C times the cosine of A. Okay. It'd probably be a good idea when you get your quiz or test, write at least one version of the law of cosines at the top of your paper so you make sure you get everything in the right order. Okay? So now let's talk through how we need to solve this. Please be very careful with your algebra. Okay? What do we need to do first? We need to subtract over 20 squared and 18 squared. So we have 34 squared minus 20 squared minus 18 squared. I know that we need to do our exponents, but we might as well do multiple things at once since we have our calculator. So we have 432 equals negative 2 times 20 times 18 is negative 720 cosine of A. Okay, now what do we do with negative 720? Divide it. So 432 divided by negative 720. And then we need to, okay, so inverse cosine, 126.87 degrees. Okay, I'm going to go ahead and I'm going to save that as A for angle A. So now we know that this angle is 126.87 degrees. Okay, technically now we have a side-side angle, and so it is possible to use the law of sines. Since we found that obtuse angle, we will not have to worry about the ambiguous case. All right, so we can switch to the law of sines. Which angle would you like to find next? Sure. So the sine of C over 18 equals the sine of 126.87 over 34. Okay. So what we have on the right side over there is the sine of angle A divided by 34. And then we have to multiply that 18 over to the other side. And then what do we have to do with that number? Inverse sine of that number. So angle C is 25.06. Anytime you have two angles, just use the rule of 180. It's important that your angles add up to 180, and this is the safest way. If you mess up on an angle, then at least your angles would still add to be 180. Okay. So what would angle B equal? This is too much. 28.07. Okay. Do our sides and angles make sense? 34 is our biggest side. It's across from our biggest angle. Side B and C are significantly smaller than side A. And those angles are quite a bit smaller, where the angle C is still just a little bit smaller than B, because side C is a little bit smaller than side A. Okay. On Wednesday, you learned an area formula. What was that? Great. 1/2 times side times the sine of the included angle. Okay? I just kind of paraphrased what Courtney said. All right? So we have an area formula, obviously, when we know base and height. But when we know side, angle, side. We also have a formula for area when we know, I don't know what happened there. When we know side, side. Okay? So I'll have you go ahead and copy down this formula, and I'll explain what it means. Does this look familiar? Maybe, maybe not. Okay, so our area formula, which I really don't know why area is labeled as big S, but I think that's how it is in your book. The area is we're taking the square root of S times S minus side, S minus side, S minus side. Where we find this little s by adding up our three sides and cutting that sum in half. So the first thing we need to do is find that little s, and then plug it into our area formula. Okay, so here's our example. I'm giving you that side A is 43, side B is 89, and side C is 120. So, first thing we need to find is little s. We're going to take half of the sum of these three sides. So, little s is 126. Is that what you're getting? Do it typing correctly. Okay. So then our area is the square root of s times s minus a times s minus b times s minus c. Okay. Now, instead of finding each of these differences and then taking the square root You're going to type things into your calculator anyway. Just type it in the way that you see it. So the square root of 126 times 126 minus 43 times 126 minus 89 times 126 minus 120. Okay, you're going to have to type all those in anyway, just do it all at once. Okay. So our area is 1,486.98 square units, whatever the units may be. Yes.
Why do you put 126 or 120?
Oh, I didn't want to. Okay, so that's not the right answer then. Thank you for catching that. That's the right answer. Talking and typing sometimes. See, multitasking is not always the best option. Is that better? I just think it's a time saver if you just punch it in all at once. I have kids who try to do each difference and then write it down and then multiply it out and write it down and then take the square root. As long as you write down the initial setup of the problem, you can do everything in your calculator. I'm okay with that. All right. All right, so we have about 10, 13 minutes left. You can go ahead and get started on your weekend's assignment.